Alright guys, welcome back to the channel. We're going to be solving another question from the third chapter of the Meriam textbook, Engineering Mechanics. And this is going to be an interesting one. There are a lot of details in this. So we have a tailgate OBC that is attached to the rear of a trailer. Y hinges at point O. So we have a hinge at point O, you can see, and there are two restraining cables AB. So we have two cables in here. One, obviously, we can see at the front. There would be another one at the back. And we know that the weight of the tailgate is 120 pounds. It's 4 inches thick. So we're talking about this, and I try to draw a line in the middle, which is going to divide this in two halves, each of them 2 inches. So the thickness is 4 inches, and we have the center of gravity at point B, which is here, exactly at the center of this part of the system, and the crate is centered between the two cables and also weight. So we're talking about this, which weighed 200 pounds, and we also have the center of gravity G, and we need to determine the tension in the cable. So as I mentioned, we have two cables, and the question is asking for the tension in each cable. So as always, we're going to start with the free body diagram of the tailgate and the crate on top. So at point B, we're going to have the tension from the cables. So I'm just going to show it with 2T since we have two cables, and that way we can find the tension in each cable. I showed the other forces. We have the weight of the crate, which we know is 200 pounds, and the weight of the tailgate, which is 120. So 120 pounds here, and at point O, since we have a hinge, we're gonna have OX and OY, and we can call our X and Y in this direction. We have a 20 degrees angle in here, which means this angle in here would be also 20 degrees. So I'm just going to show that in here, 20 degrees here, and we're going to have the same thing for the other one, 20 degrees. And we're good to go to use our equilibrium equations. And since we are interested in T, if we just do the moment about point O, we can get rid of all the unknowns at O, and we're going to end up with T. But if we want to use our 2D shortcut that we have to resolve the force and the tension in the cable into two components, one in X direction and one in Y direction. So for that, we need this angle here, which we can show it alpha. And for finding the alpha, if we look at this orange right triangle that we have in here, for tangent of alpha, we need to find this side in here and the base of this right triangle. So if we look at the figure from A to O, we know is 30 inches. So we have this part 30 inches, and we have to figure out the other part, which is probably the trickiest part of this question. So for that, we are dealing with two different right triangles. So as I mentioned, I tried to draw a line at the center of this tailgate, because you might say that we know that the half of the tailgate is 21 inches, and we know that this angle also here is 20 degrees, which is basically this angle in here. And we're gonna have this right triangle. I'm just gonna try to show it with different color, maybe light blue. So if we look at this right triangle here, we know that the hypotenuse is 21 inches, this angle is 20 degrees, and if we can find that side, we can find this side in here. And for finding the tangent of alpha, as I mentioned, we had 30 inches plus the light blue part, which is going to be 21 sine of 20 degrees, plus we're going to have another right triangle, which is the red triangle that is on top. I tried to show it bigger in here. So we need this little side in here, which is what we have on this side. And for finding that, that's actually not that hard too, because it will be 2 cosine of 20 degrees. One common mistake that you guys might make in here is that, so for the yellow triangle or the big one, let me try a different color for, so for this right triangle, you might just say that, okay, this is 30 and this part would be 21 sine of 20 degrees, and you're gonna missing this little part in here. So that's why the figure is a bit complicated in here, because you might miss this part and it might mess up your answer at the end. So since there is the point B is at the center of that beam, we are dealing with that little distance that I'm trying to color coded in red. So just watch for that. That's why I tried to make it a little bit more complicated in this question, but it's not actually that complicated. I'm just trying to show everything a little bit bigger, and you guys can see better. All right, so let's go to the base of that yellow triangle. So I'm talking about this. So now we are trying to find this one, the side. So let's see how we can find that one. So if we get back to our blue triangle, so this side would be 21 cosine of 20 degrees. But what we are interested is the base of the yellow triangle. Let me just highlight this triangle. So we are interested in based on this right triangle, which as we can see, we need to subtract the red part from here in order to get that base. So 21 cosine of 20 degrees minus this time we have to subtract this side of the red triangle, which this time will be 2 sine of 20 degrees. So that was the hardest part of this question. The rest is pretty easy that now that we have all of angles. So we just need to calculate alpha, which would be the tangent inverse of what we had in the previous step. So let's just calculate that. So we're going to have tangent inverse of 30 plus 21 sine of 20 plus 2 cosine of 20 divided by 21 cosine of 20 minus 2 sine of 20 degrees. Let's see what we get. So this is going to give us 64 degrees, which would be the correct angle for this. Again, don't forget to include these two in your calculations. If you see that your answer is a bit off, it's probably you missed that part. But now it should be pretty easy because we figure out that angle, and for finding the moment about O, we just have to resolve these forces. So again, we are trying to find the moment about point O. So now that we have that, this would be our 2t. We're going to go with this point because that way if we resolve it in these two, we're going to have only the moment of the x component, as we can see, will be clockwise, so negative minus 2t cosine of 64 degrees, and the distance would be the distance from O to A, which we figured it's a given in the question, so 30 inches. That's pretty much for the t. And we're gonna have the moment of the two weights that we have, one at point B. So let's move on to the moment of 120-pound weight at point B. So I'm just showing that we can resolve it in these two directions because vertical distance to the line of action is pretty easy. So we're gonna have the moment of this component, which as we can see will be clockwise moment. So negative 120 sine of 20 degrees, and the distance would be half of the bar, which is 2 inches. And the other component will be counterclockwise moment, so it will be positive 120, this time cosine of 20 degrees. And the distance is half of the tailgate, which we know is 21 inches. And the last thing is the moment of the crate. So we're going to do the same thing. This will be one component, this will be the other one. So let's start with the one parallel to the tailgate. So the moment it will be in this direction, so counterclockwise, positive plus 200 sine of 20 degrees, and the distance would be the length of the tailgate, which is 21 plus 21 minus this distance 14, so 42 minus 14, and the distance would be the vertical distance to the line of action, which is what we have in here, and we know that's going to be 6. And the vertical component to the tailgate is also counterclockwise, so this one's positive to 200. This time we have cosine of 20 degrees, and the distance would be what we have from here to here, which is the length of the tailgate, 42 minus 14 equals 0. And now we should be able to find the tension in the cable, which is going to be 2t cosine of 64 times 30 is equal to the rest of our equation. Let's just calculate everything on the other side. So I'm going to start at the end, 200 cosine of 20 times 42 minus 14 plus 200 sine of 20 times 6 plus 120 cosine of 20 times 21 minus 120 sine of 20 degrees times 2. And we're going to divide this by 60 cosine of 64. So that's going to give us our T, which is going to be 302.58 pounds. And the final answer for this question, hope everything was clear. This is just a little bit more complicated question, but if you understand this, you should be more than good in this topic. And yeah, you guys take care. I'll see you in the next video. Have a good one.